Yes, and we did not totally grasp it on Friday. So we started with a flashback of what you were supposed to learn in Chapter 5. Do we always learn everything we're supposed to learn when we're supposed to learn it? No, but what's different about Algebra 2 than any other course in math so far is we have an end of course exam. So what you don't get, we need to get by May. All right, the nth root of a, if I say that n equals 3 and a is negative 216, do you know how to set it up from just this information? So negative 216, and Selena said the cube root. The nth root of a would be the nth root of a, and you subbed it in perfectly. Now, how do you get an answer for that? You could go to math. You got to put the 3 in. Let's practice. Put the 3 in. Go to math. Is it number 5? To do an x, oh, it's a cubic, okay. Number 4. Do you have to hit enter after you hit 4? Oh, we don't have to, you're right, we do not have to put the 3 in there. Good. Math, number 4. Do you have to hit enter after that or just the 4? No? And then it's going to give you 3 and a box. And what do you put in the box? Good. And then what did that give you? Can everybody do that? Now let's do one that you have to create the little guy. N equals 4. We're using the same directions for example 1 and example 2. Let's let n equal 4 and a equal 81. You might know this one already. Good. Just practice on your calculator. Go ahead and put your 4 in, hit math, and which one do we hit when it's not a 3? Number 5. And then it'll put the 4 in for you, give you the box. What goes in the box? 81. And did everybody get 3? Good, 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 good. All right, so you've got that from Friday. What is the name of this position vocab-wise? Anybody remember that, what that's called? Root or index number. Okay, root or index number. Rational exponents look like this. And they could have a negative on the exponent. If I want to rewrite it from exponent form to radical form, help me get started, Riley Gransberry. What would you do first? What, babe? What has to be in a radical? A radical. So I, Riley, would start with a radical. Now, does that help you at all? Okay, pick one thing, A, M, or N, and see if you can place it correctly. Perfect. A goes under the radical. Perfection. Now, round robin, you pick the next person to tell me where M or N goes to. Keandre, you're up. M or N. Where do they go? M or N? The index number. Good. You, round robin, pick the person who's going to give me where M goes. Above, or superscript, right? Now this is equivalent to, we worked on this on Friday, that the M can go under the radical as a power of A, or it can go outside, totally outside it, and be a power of the whole radical. Either way, we got the same answer when we worked problems like this. Now, what if it were, let's see, that's example 3. Let's throw out an example 4 that looks very similar. How would you guys take care of that guy? First worry is what? Harrison, first worry up there. Mm-hmm. Okay. Round robin, pick the next person.
You mean the Januaries were west? You have to put the in where the index number.
Okay. Round robin, pick somebody. Lincoln. Okay. Pick somebody. Theoretically, yes, but first, the very first thing that is not your fault they missed it, we should have said 1 over a to the mn, and then Ashby, your answer about m would have been right. What's the first thing that should have been done? Won't be the first, won't be the last. Join the club. Perfectionism is overrated. A to the negative m over n is 1 over a to the mn. Then go through the same process you did on example 3 and you'll be fine. Now let's do a real one. Let's do an example that requires you to use what we've just talked about. What can you do with 32 to the negative 3/5? Let's start with Hunter. Tell me something to do first. Yes, first thing, yeah, I know what you meant. 1 over 32 to the 3/5. Round robin, you pick the next person. Okay, you're going to put the 32 under first. All right, round robin, pick somebody. Good. And pick the last person for this one, Harrison. No, call on somebody. No, he's already gone. Good. Now, it's not rationalized. You can't leave it that way. We're not going to talk about that right this minute. One of them would rationalize away and be, why would I write one of them like that? Does anybody know from what we talked about on Friday? Oh, I can't do that. Shoot, sorry. I tried to make up math. I need to get this 3 to be a 5. Do you know how I can get that 3 up to a 5? Anybody know? How many more do I need of 32 to the 3rd to get it up to 5? 2. But if I stick it in the bottom, what else do I have to do? Put it in the top, right? And I'm just showing you this. We're not really going over this yet. What do you do with the 5th root of 32 to the 5th? What do you do with the 5th root and the 5th power? Cancels out. 5th root of 32 squared over 32. Now can I leave it? Yeah, there's no radical in the bottom. What was the problem with this radical right here? Not allowed. It's irrational. The 5th root of the 5th root of 32 to the 3rd is a decimal that never ends. That's irrational. So we have to find a way to make it rational. So how did we do that? We bumped up 32 to the 3rd all the way to what? 32 to the 5th. Once you did that, the power and the root matched, and you could cancel the power and root and have your rational 32. The key here is not to think you can cancel out of the radical and the denominator. They are unlike terms. Everybody do, let's do this. Irrational. The 5th root of 32 to the 3rd is irrational. You got 8? Seriously? I don't know. Okay, let's see. The 5th root of 32 to the 3rd must just simplify. So that means if this guy's 8, do the 5th root of 32 to the 2nd and see what happens. Okay, so the fifth root of the 32 to the second is really simplifies to be 4, so what's our final answer? 1/8. Good job, Wes. We didn't have to do all that work on that one, but that's how you do it if you have to do the work, okay? Sorry about that, guys. All right, example 6. I want to know how to go from this form, radical form. I think I'll give you a point for that, Wes. That was good. The fourth root of 7 to the third, go from radical to exponential form, please. Can you do it? Spinda. What's my base? 7. Round robin, call on somebody to tell me another piece. Either tell me the index or the power, how to rewrite it. Who did she say? Madeline. Sorry, what? It is 4, but where does it go in the exponential form? I agree with you, the index is 4, that's right, but we have to change it to exponential form. Where does it go? You have a 50-50 chance. Does it go in the numerator or the denominator of the new term? Good, the denominator. Did y'all notice how she kept looking back to her notes? She wasn't sure, so she kept looking. Good job. So that left the power of 3 to go in the numerator. In your calculator, put 7, then hit the caret key, then hit alpha y equals, put that little number 1 in there, and put 3/4. Tell me what kind of answer you get. Like, does it ever end, or does it go all the way to the edge? So it's irrational.
My nose just started bleeding. Can I go fix that?
Mm-hmm.
Okay.
All right, the reason that we are working on rational exponents is because there will be questions that you have to solve, and we will need different types of radicals than we've used in the past to make it be able to solve. So first, whatever you have, you want to get it by itself with its exponent. How do you undo the fourth power? You undo it with the fourth root. They're opposite operations. What do you do with -3? You're going to add it to both sides. And one key that I'm always afraid people are going to forget is the plus or minus part of taking an even root of both sides. If you were asked for the irrational solutions, you'd go to your calculator and say 3 plus the fourth root of 21, and that's going to give you that irrational answer, 5.14. And then I would just hit second enter and bring it back up and just change the add to subtract to make it faster. Second enter will bring it right back up. The other one is 0.86. And you have two irrational solutions that hit the x-axis but not at an integer or a rational number. They're both irrational. All right, how would you attack that one to solve it, Dylan? You be my first person. Tell me one step you would do to isolate x to the third. I want to isolate x to the third first, so step back one step. Right, either divide it by a fourth or multiply it by its reciprocal. Either one works. Now pass it to somebody, Dylan. Okay, cube root of both sides. Why do I not have to worry about plus and minus on that one? Right, it was the odd root instead of an even. Good. All right, so today's hopefully looks easier than it did on Friday just because we've seen it again. You flashed back. We took a whole extra day to flash back to 5-1, which was the integer exponents. If there was a question and you didn't ask me about the worksheet from Friday night, just ask me. Even though not right this minute, I will still help you with it when you get it back. There are quite a few practice problems, more than I usually give. First, you're going to go 3 through 6. Seven through 35 odd. 51 through 57 odd, and that's significantly more than I usually give. You have about 20 minutes to get more than half of them done. The activity today is to work the rest of class by working questions, asking questions. You can check answers while you're here.